first topic of discussion today will be binary 1:1 relation mapping into table structure. How do we map a normal binary 1:1 relation into table structure? Okay. So let's take a very basic example of 1:1, which is staff and contract. Okay. One staff may or may not have contract, but one contract is definitely must be linked to a staff only. That means in this case, staff is on the mandatory side and contract it is in the optional side. So how I can map this kind of ERD diagram into table structure, right? So for that, the rule is primary key on the mandatory side becomes a foreign key on the optional side. Now, primary key on the mandatory side means staff number or employee number. Over here, I have shown staff number as the employee number in this case. So you have to give the same name. So EMP_NO is the mandatory side primary key. So that should be included in the contract table, which is having contract CONT number or contract number, start date, end date, position, salary. Along with that, EMP-NO will be also included. So a 1:1 relationship, if you want to map that thing, then the simple rule is primary key on the mandatory side should be included as a foreign key on the optional side. But there is an important note that although EMP-NO is the foreign key in the contract table, but you cannot give any null value, because normally you have seen that foreign key null values are allowed, isn't it? But in this case, the null value will not be allowed, although it is foreign key, because EMP-NO is a mandatory field, because now it cannot be null. Because if you put it null, then you cannot form the contract table. Understood? Next, we will learn how we can map a binary 1:m relation into table structure. Again, I have taken a very simple example, course and student. Understand? Course and student. This is having a 1:m relationship. So how I can map? The rule is that the primary key on the one side of the relationship, one side is the course side, right? The primary key on the one side of the relationship is added to the many side as a foreign key. Many side over here is student, right? So before this ERD diagram was mapped, before course was course number and course name, student was student table was roll number, student name and date of birth. But after we have taken care of this matriculate relationship, then course will have course number, course name, so no change in course table. But student table will have roll number, student name and date of birth will remain intact. Along with that, course number will be included. And what is this course number? This is nothing but the foreign key of this relation, because course number was the primary key of course table. Now it is used as foreign key of this table. Understood? So in this way, I can map 1:m binary relation into table structure. Then we will see how we can map binary m:n relationship. This is a very interesting case. Okay. Now look at this case, student and course. Suppose the relationship is like this. One student can enroll himself in many courses, and also one course can have many students. So this is an m:n relationship, right? Then how can I create table structure for this thing? Now let's first understand the rule. First rule is create a new table, new relation or table. Include in it two foreign keys, one from each of the participants in the relationship. I will tell you in the example. And third point is the primary key of the new table is nothing but the combination of two foreign keys that you have taken from the other table. So let's take the example in the next slide. Course. Course is having course ID and course name, where course ID is the primary key. Student is having student ID, student name, date of birth, address, but student ID is the primary key. And what about the second one? Now look at these two primary key, but the relationship is enrolls, right? As you have seen in my just previous slide. So enrolls will have primary key of course table means course ID, and Primary key of student table means student ID. These two primary key will be acting as a foreign key in this enrolls table, but taken together, they form the primary key of enrolls table. That means after mapping an M is to N relationship, we are not generating two relations. We are having three relations, three table structure. One is the original course structure, course table structure. Second one is the student table, and third table is the enrolls table. That means after mapping M is to N relationship, we are generating a new table. In this case, it is named as enrolls, which is having the primary key of other two tables as foreign key, and those two foreign keys taken together will serve as a primary key. Understood? Of enrolls table. So I think now this is clear. If you have got any doubt, please ask me in the comment section. I'll be very happy to answer your question. Then I will think that my lecture is successful, because my students are learning something that gives me, believe me, immense pleasure. Okay, so with this, I'm concluding my lecture, my dear students. In my next lecture, I will complete this table structure mapping thing. And with that, we will be finishing this entity relationship model chapter. Okay, so bye for now. Take care and have a nice time.